Hello everyone, it's October 25th. Alright, let's go right into it. Continuous subarray sum. Still rolling. There we go. What is this? Done it before. Give an integer array nums and an integer k. Return true if nums has a continuous subarray of size at least 2 whose elements sum up to multiple of k, or false otherwise. Integer x is a multiple of k if there exists an integer n such that x equals n times k. 0 is always a multiple of k. Okay. Interesting. Multiple of k. Most likely dp again, so we just need to figure out how to dp this stuff. Let's see how we're going to dp this. So let's see, 23, 2, 4, 6, and 7, right? So what we want to find out is multiple of k. Multiple of k. Interesting. Multiple. Now k is a certain value. Damn, k is huge. So a multiple of k, which means value plus the current value is going to have to be 0 or k or 2k and all the way up, which means the remainder of the previous value, mod k, must equal to the current value for it to work. Which means if I know all the remainders, right? If I know all the remainders ending up at this position, all of them, right? If I know all of them, and this is unique, if I know all the remainders of all the sums ending up at a position, now we go to the next position, right? So we can check if the next value is inside this set. If it's in, we return true, which just no trouble, no problem about it. If it's not in, then we need to add, right? Well, this is where we can be a little bit smarter because we don't have to add to all of them, because when you add, depending on the previous remainder, because this, what was the theory? If you add something and if the sum add this mod equals this mod and then this mod, so we do mod of the current value, right? And then we add to all of them. But how can we simplify this process so we don't have to add every single one of them? Well, what I can say is, let's say this is 6, this is 4, right? Now this is 2, and the previous one needs to add 2. Or maybe we should have a list of all the values, all the remainder that has not been encountered. Okay? So we have all the remainder that has not been encountered. Then, if the current value is not in that set, then we're done. Right? If the current value is in the set, that means this one has not been encountered. So I need to add myself to it, right? If I add myself to it, then I can do myself mod this thing, mod k. And then that will be the remainder to add, right? That will be the remainder to add. So if that's the remainder to add, and then if I add something, then would it be hitting something that's already, then we will do, oh no, we still have to check every single one, right? And we have to check if they exist. No, 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 no. This doesn't sound right. This doesn't sound right. Because k can be huge, right? 2 to the 31st. Now if we go through all of them, that's a large value. That's a large value. And how do I update the remainders? These are just the previous remainders into plus the current one. How can I know, to be fast, to know which one needs to be fit? So if I have a list of values that has not been handled, then I go through them. I don't think that's basically the same thing. We have to go OK, like ONK. That seems to me is just gonna time out. No. What if I mod everything? If I mod everything, then the problem becomes, can we find a subarray sum equal to k, right? Or equal to a multiple of k. Subarray sum. How do we find a subarray sum equal to something? Let me try something. Okay. Then what? We'll need to find. This is the sum. So something minus something, right, is equal to either 6, either k or 0. No, it won't be k. It should be equal to 0. Which means add together it's 0. This might be right. We can do this. We can do this. And everything will be okay. Then we just need to see if it's possible to have, yeah, we're going to do prefix sum, and then we take modulo of all the prefix sum, right? And then any subarray sum is just the modulus subarray sum, one value minus the other value, right? And then that's just the remainder of that. And then if the remainder is 0, then it's good, which means we search for the whole thing. As long as there are repeats, then we're good. So I'm going to approach this problem like this. We're going to do a prefix sum, and then modulo it. So from the tools, import accumulate. Okay, now we say accumulate nums, and then for a in this, we do a modulo k. So we say mod prefix mod, pref mod, okay, goes this. And we say return 0 in pref mod. Oh, cannot be the first one. And pref mod 0 is not equal to 0. Okay, that's 1. Because 0 at any position is working, but 0 at the first position doesn't work. Or len set pref mod is smaller than len pref mod. Something like this. Okay, I'm gonna give it a shot. This is true. This one is also true. This one is false. Nums k. Oh, at least these pass, but we can do some edge case. 24, right? That is an edge case. 24 and 24. The first one should be false. Yeah. Try this. Wrong answer. 0 is really messing me up, I guess. Shoot. Expected false. 1 and 2. So we have 1 and 0. No, it should be 1 and 1. Holy moly. 1 and 1. Need more check. Yes, we have modulo, but we have to check the sum as well. Damn. Easy way to do this? Yeah, now we just say if we have the equal ones, right? But the equal ones, they might not be big enough. But hold a second. If they are equal, if the two are equal, and then it's adding, right? The only possibility is if we have 0. So maybe we just need to remove all the zeros, right? Because 0 is not contributing, so we should remove all the zeros. We remove all the zeros, and we remove all the zeros, then it's guaranteed that if the two are the same, the sum cannot be the same, right? The sum would definitely increase. So if the first one we hit is when it's smaller, then the second one we hit must be it's larger. Therefore, and then all the values are positive. So that's another thing that we can take advantage. So we say for n in this, right, if n is not equal to 0. So I'm going to change this and try again. Man, I'm kind of thinking we're repeating the same thing. Oh, it's so sad. Oh, didn't see this one coming. Damn. I cannot remove. Oh man. Okay, so I mean that's a special case, right? Consecutive zeros. So we just do consecutive zeros. How are you gonna do consecutive zeros? Oh man. All right. This is ridiculous. Cleaned non-zero nums and 0 indices, right? 0 indices. For n in nums, for in enumerate nums. If n is equal to 0, 0 indices are append. Let me say if 0 indices minus 1 equal to I minus 1, return true, right? Because it was 0, 0. Otherwise, 0 indices dot append I. Else, non-zero. Nah, we might as well just do this. Pref mod equals this. Then we just said pref mod. We'll put a 0 here. Nah. Dot append. If not pref mod, else, right? Append what? N mod k. Otherwise, pref mod minus 1 plus n, right? And then mod k. you. And there we go. Okay. What else can you throw at me? Come on. Throw it at me. What else can you throw? Dude can really throw something at you. Expected true. Now it become 1. Okay, this one will be 0, 1, and 1, right? So what I need to know is, because if we do mod, that will be 0, 0, and a 0. Right? Yeah, we can actually throw some like this. That should be true as well. Right? Maybe what we need to do is just to go through all of them, right? When I go through this, we have the indices, right? And then we just find the sum. So, like, yeah, my current thought is actually we're gonna get prefix sum. Pre-sum equal to list accumulate nums, and then pre-mod goes to ps mod k for ps in pre-sum. Okay, so then actually, so it's a pre-mod dict. I say default dict list. Okay. Then we say for ps in pre-sum, enumerate. Right. Then we say pre-mod ps dot append I. Right. And then we say if len pre-mod dict. I just did I just say ps? Let me do it. We say if I minus. We do this first. If pre-mod I minus pre-mod dict ps 0, right? If this indices, right? Plus 1 is the total length. Wait, hold up. So we have this and this, right? So what we say is to this, the sum mod is this value. To here, the sum mod is this value. So the things in between, right? The things in between is mod is 0. So it should be this minus this, right? Because we want to know what's the number of things in between. 5. Yeah, that will be 5. Which also means we shall have a 0. Yeah, I'll do this 0 dot append 0. Okay, and then enumerate. I think I can start from 1. Then we'll do this, and then we say if this minus this, right, this is the number of things in between. If this is larger than equal to 2, right? Larger equal to 2, and then we need to say and pre-sum. Okay. Oh, pre-sum. I'll put a 0 as well. Hold on, maybe accumulate I can do this. Nope. Accumulate doesn't have a start. Initial. Yep, that's what we want. Initial. So with initial, we don't have to do this. Okay, so pre-sum have this. Now we say this, and then pre-sum I minus pre-sum this one. I can just say j equals this, right? And then we say if this minus j is larger equal to 2, so we have at least 2, and then the value is larger equal to k. Right? It has to be larger or equal to k. Which is the sum is larger equal to k. Then we will return true. And if not, we'll return false. Try this. List out of range. And we are wrong in the initial. What the hell? Yeah, let's see. Predict and then pre-sum ij. Oh, 0, 23, blah blah blah. Add 1. Oh, I am right. 3, 25. Ooh, we added 25. That is not right. I forgot to mod it. Sorry. Forgot to mod. Should be M. Presum should be M. There we go. This one is right. Number 4. 0, 1, 2, 3, 4. So why is this one not right? So this one, presum, we actually do presum, right? So we can do presum, and then we try to see the predict. Okay, so presum is 0, 5, 5, 5, 5, exactly, and then 2. Oh, larger equal to k, or it can be 0. So if this and this is larger than k, or these two are the presum, or these two are the same, right? Then it's true. Because if they're the same, that means they're equal. Okay, so this is a new attempt. As long as I can finish this with fewer attempts than last time, that's a win. All right, try this one. What else can you throw at me? What else can you throw at me? What else? Come on. I ain't afraid. I'm not afraid. Yup, they don't have more to throw at me. So, some improvement. Last time was 1, 2, 3, 4, 5, 6, and then I got it. This time is this. But let's check the solutions. Man, so this problem is, yeah, I kind of remember. 529, 523. So this problem is notorious for its many tricky test cases, edge cases involving 0. Now the basic idea is to create a prefix sum, a prefix mod, which is composed of prefix sum mod k. And as long as we have 0 or some repeats of prefix, we will have a high chance to get a sub-array sum to be multiple of k. However, the tricky part is that with 0 in the mix, sometimes the in the mix we have a lot of conditions to consider, right? For instance, 0, 1 with k equals 2, right? 0, 1 with k equals 2 is false. But if we just check 1, 0, right? 1, 0. If we just check for a 0 not in the starting position, we would be wrong, right? Yeah. Now, if it's false, but its prefix mod is 1, 1, right? Which seems to be good, but it is not. But it is too short, not too short. Yeah, it is too short. Also, 5, 0, 0, 0. Not 5, 0, 0. It's 0, 1, 0. Right? With k equals 1 is true. Right? Oh yeah, but the thing is which seems good. So my initial idea is to get rid of all zeros. But then I have tests, and then I fail, right? And I fail test cases such as 5, 0, 0, 0 with k equals 3 and this. Eventually, I decided to not use any fancy method. We simply create both the prefix sum and prefix not for each possible, right, case in prefix mod. We check the length of the subarray and the sum of the subarray before making the decision. This turns out to be correct. ON with a not so good runtime. It could be they increased the number of test cases. It's very likely. It's 8 months. 8 months. 95. 97, so we have a bit more. Okay, 95. Trick is with the mod. Oh, yeah, we don't even have to. Oh my god, we just need to find the first one. That is true. All right. We have a hash map to record the first thing, right? The minimum of the two. And then we will say, it doesn't make me feel there should always be. I don't know. And we say pre-sum yes, and now we get if I is larger than this plus 1, then I can return true. But what if and we don't have to check. We don't have to check for this. No, we don't have to check it's larger than k. We don't have to check it's larger than k. Because if it's not larger than k, that means it's has a 0. But if it's larger than 2 and it's still, that means at least have 2 zeros, right? Otherwise, it's not possible. So we can remove this and it's still pass. But we're gonna write solution number 2. Well, same idea as solution 1, but 2 key insights. First, we don't have to keep a list of pre-mod indices. We only need the smallest. We only need the index of the first occurrence. Index of the first occurrence of a mod value. We don't have to check for pre-sum I minus pre-sum j, because larger than k, right? Because if it's smaller than k, there's smaller than k, it's impossible if I minus j is smaller than 2, right? But it is possible if I minus j is larger than or equal to 2. This is the case where we have multiple zeros. Multiple consecutive zeros, actually. Just think about it. Yeah, otherwise it's not going to be happening. If you have multiple, they're all the same, right? And it's this and this is always going to work. It's always going to work, even if it's smaller. Because it's the same, it would just be multiple zeros. Yeah, so it's always going to work. So all we need to do is PS is going to be 0, right? Pre-mod dict is going to be 0. Yeah, we can set to -1. And then for I, any enumerate nums, and we say PS equals to PS plus M mod K, right? Then what? Then we say if I minus pre-mod dict dot get PS, right? What do we get? 0, right? If it doesn't exist. Index minus, if it doesn't exist, actually, if it doesn't exist, I'll just use I. If it's large equal to 2, right? That will just return true. Otherwise, we say pre-PS shall equal to minimum pre-mod this PS get PS. it's not in it, then prima this ps equal to I. Then we say if this, alright, then we don't have to do this. Then we return false here. Okay. Yep. Okay, so this is a better solution in my opinion. It's better. Yeah, not necessarily faster, but I think it is better. Okay, done with this. I don't have much time. Fancy. Let's try this. Let's take a look. If it's too hard, then we just do it some other time. Sum of beauty in the array. A zero indexed array. For each index, for each index I, 1, 2, so excluding the beginning and the end, the beauty of nums I equals 2 if this nums JIK for all to the left and for all to the right, so that's 2 points, if I minus 1 and the previous condition is not satisfied, 0 if none of the conditions holds. Return the sum of beauty of all nums I for all nums I, where, so we only have 1 for this one. In the range, yeah, the beauty of, because everything to the left is smaller, right? And everything on the right is larger. And this is 4 and 6, example 2. So example 2, first one doesn't hold, but the second one holds, so that's a 1. And 6, none of them hold, so that's a 1. Okay, I think I see what this one is about. So basically we say we're given an array of values, right? Test case will be easy to generate. I like that. And then we have the middle things. So we pull this one out. So we want to know, well, first of all, I want to know if there are anything to my right and to my left that's bigger than me, all right? It's bigger than me. So I might just keep the largest value on the left and the smallest value on the right. What do you think about that? I think that's a very valid point. But how do we handle this? Well, we can get the mean value right up into this one, but then how do we know what is the, if the mean value gets popped, what is the next mean value, right? So we need to do a prefix min on the right hand side, okay? A prefix min, and actually it'll be easier if we do a prefix max on the left hand side. So we do a prefix max on the left hand side. We can get everything, which is okay, but we have to record every single one. And now we have the prefix max, so which the max in between here. We have this value, and then we can do prefix min from right to left, and then we go through, and then we say we check if it holds. So it's on. Okay, let's see if we can code this up in 10 minutes. See, that, my friend, is a challenge, but it shouldn't be too bad because I already have an idea how this one shall be going. Ain't afraid of coding it in 10 minutes. All right, so we're gonna say pre-max equals this, right? And then we can say nums 0, right? And now we say for I in range 1 to, actually I can just do len nums minus 1, right? We say premax dot append maximum prefix max minus 1 and nums I. So we have this, the rest is going to be 0, and then for j, and then pre-min equals to nums minus 1, right? And then for j in range, len nums minus 2, right? Minus 1 I cannot do, so minus 2 all the way to 0, because I cannot hold 0. So in this, and we say if nums j, so it's going to be premax j minus 1, right? Premax, that's a j here, so premax j minus 1. Oh, in that case, oh yeah. Ooh, we have to go all the way to the end. And then they'll be the same size, so what can use this will be easier to handle. So I just say j minus 1, that'll be easier. Alright, so this is j minus 1, right? If this is smaller than nums j, smaller than pre-min, then rest plus equal to 2. If nums j minus 1 is smaller than nums j, smaller than nums j plus 1, this is actually exactly copying this. Rest plus equal 1. Else we just don't do anything. And then pre-min equals to the minimum of nums I, nums j, and pre-min. Right, we can get a minimum value of the largest on the right. So we go this, and now we return rest. Okay. We have 3 minutes left, so let's do some test cases. Of course, we're going to test this, and once this all pass, we are going to test on some randomly generated stuff. Okay, I'm gonna copy and paste, put it here, and then go back here. We can do 100 from random import randint. This in range, let's do 10. Let's do 20 test cases. Print for this in range, so 100, and randint to 1 to 100. Let's do 1000. That's for fun. All right. Let's get all of these and one for good measure. See if it works. Yep, think this one's fine. Oh, I have 6 more minutes. Yep, it works. Kind of slow though, but yeah, it works. Prefix max on the left side, prefix min on the right side. And for each, and we go from right to left, compare to the max on the left and the min on the right, to decide, right, whether to decide the score of the current value. Now there's on time and on space, which I think, can we do better? Maybe we don't need this part, right? Can we just go? I mean, I don't know, because you have to, right? Yeah, I don't know. Let's see. Any smart solutions? Mm-hmm. Mm-hmm. Yeah, you have to compute. They did compute. So, it's the same. You have to compute. You cannot avoid this, right? All right, that's that. We're done. 10 minutes. So some are not as difficult as the others, unless somebody have a O1 space. Max heap. I can do max heap. Well, max heap will be O1 log n, right? That'll be it. All right. I will see you guys tomorrow then. Adios.